All right, let's jump right in. Large language models are absolutely incredible when you're just playing around with them in a sandbox. You ask a question, it spits out a magical answer, and wow, it feels exactly like the future. But taking that magic and moving it out of the sandbox to build reliable production-grade applications, well, that is a massive challenge. When real users, real data, and real business stakes are on the line, you just can't afford hallucinations. You need architecture. So welcome to this explainer on the RAG architecture landscape. Today, we're going to look specifically at how to scale your system from a basic standard setup all the way to a highly accurate corrective one. Now, looking at this really shatters the myth that there's only one way to build a retrieval augmented generation system. The process of giving an AI a specialized database to read from so it gets its facts right. Look at this. There are 9 distinct architectures listed here, from standard RAG all the way up to SAM-RAG and multimodal setups. If you've been thinking that RAG is just some simple single plugin you attach to your app, well, consider this your wake-up call. You literally have an entire toolbox available to you before you ever even think about going to production. So here's our roadmap for today's explainer. First, we'll map out the overall RAG architecture landscape. Second, we'll look at the beginner level with standard RAG. Third, we'll level up to the advanced stuff with corrective RAG. And finally, we'll talk about choosing the right architecture for your needs. Let's kick things off with Section 1, the RAG architecture landscape. The absolute foundational rule you need to understand right out of the gate is that an architecture must actually earn its place based on your specific use case. Like we just saw, there are 9 distinct architectures in this field guide, and they range wildly in complexity, from your basic standard setup all the way to multi-model. And honestly, this brilliantly illustrates a key truth in AI development right now. There is absolutely no one-size-fits-all solution. The sheer variety here, whether you're looking at deep RAG, modular RAG, or fusion RAG, it just proves that the complexity of your pipeline depends entirely on the stakes of your project. If the stakes are low, you keep it simple. But if the stakes are sky high, your architecture definitely has to step up to the plate. Moving right along to Section 2, beginner level standard RAG. Okay, so this right here is your classic standard RAG setup. The guiding principle here is low complexity. To put that into perspective, think about a really practical example, like an internal FAQ bot for a company. Its only job is to surface up-to-date company policies. Stuff like, what's the work from home policy, or how do I expense a flight? Now, obviously, accuracy matters, but the actual complexity of the reasoning required is super low. It's just straightforward A to B fact retrieval. Let's trace how this pipeline builds out step by step. As you'll see, it's a very linear, super clean journey. Step 1, the user types in their query. Step 2, the system processes that query. Step 3, it reaches right into the database for retrieval. Step 4, it selects the most relevant documents. Step 5, it takes those documents and integrates them as context for the AI. And finally, Step 6, the LLM generates its response. Boom. It's a straight line from question to answer. It's fast, it's efficient, and it's absolutely perfect for when you just need to pull a clean fact from a reliable database. Now here is a really valuable insider tip straight from the source material if you're actually building this. When you're preparing your documents for that retrieval step, start with smaller chunk sizes. We're talking around 256 to 512 tokens. You'll also want to experiment with the overlap between those chunks. Why does this matter? Well, it significantly improves your coverage so the AI doesn't miss the context that's hiding right there between paragraphs. But crucially, it does this without overwhelming the LLM's context window. It's just a simple little tweak, but it makes a standard RAG pipeline so much more reliable. All right, let's jump to Section 3, Advanced Level Corrective RAG. So standard RAG is fantastic for answering HR questions, right? But what happens when accuracy isn't just about company policy, but is quite literally a matter of health and safety? Well, that's where corrective RAG comes in. It acts as a shield, built specifically for high-stakes verification environments. Our practical example here is totally different from that simple FAQ bot. Imagine a clinical decision support assistant. This is an AI that a doctor might use to cross-verify patient symptoms against trusted medical literature. If the FAQ bot gets it wrong, someone's just confused about their vacation days. But if the clinical assistant gets it wrong, the consequences could be disastrous. In this kind of environment, outputs absolutely must be double-checked before the user ever lays eyes on that. Let's contrast this with the previous pipeline. You're going to notice right away that it is not just a straight line anymore. Step 1 is still the user query, and Step 2 is an initial response. But then, bam, we hit a massive roadblock at Step 3, error detection. The system actually hits pause to look for flaws in its own reasoning. If it finds an issue, it triggers Step 4, which is a whole new round of retrieval, followed by Step 5, response correction.
Only after it has successfully passed these hurdles do we finally reach step 6, the final response. The absolutely crucial part of this setup are those new checkpoints at steps 3 and 5. This architecture is literally designed to catch its own mistakes.
The engine that's actually driving this self-correction is called a verification loop. I want you to think of this like a really strict teacher or a harsh grader hovering right over the AI's shoulder. Before the AI tries to hand in its homework to the user, this harsh grader reviews the work. If it spots any uncertain segments or, potential hallucinations, it grabs a red pen, flags it, and tells the system, nope, go back to the library, retrieve better information, and fix this right now. And the best part, all of this happens completely under the hood before the user ever sees a single word.
And if you're sitting there wondering, well, how do I actually build that harsh grader technically? The source gives us this brilliant, specific recommendation. Use a lightweight verification loop, either a separate classifier or an auxiliary LLM. This is such a smart strategy, because instead of relying on your main, highly complex LLM to police itself, you just deploy a smaller, separate AI model, an auxiliary LLM whose only job is to act as that verification loop. It does all the heavy lifting of fact-checking securely and efficiently, which keeps your main pipeline running completely smoothly.
Finally, Section 4, choosing the right architecture.
Comparing these side by side really crystallizes everything we've been talking about today. On the top row, you've got standard RAG. It's beginner level, perfect for low complexity fact retrieval, just like our FAQ bots. On the bottom row, you have corrective RAG. It's advanced, and it's explicitly designed for double-checked outputs, like those clinical assistants we discussed. The big takeaway you need to walk away with right now is that choosing between these isn't about which one is inherently better in a vacuum. I mean, a sports car isn't better than a tractor if what you really need to do is plow a field, right? It's all about perfectly fitting the architecture to the specific stakes and complexities of your exact needs.
And that leads us to the ultimate question you have to ask yourself and, frankly, your engineering team. Which architecture does your production environment actually demand? Are you building something where speed and simplicity are the absolute keys, or are you building something where a single error could be catastrophic? Let that question guide your entire development process. Thanks for joining me on this explainer, and I really hope this gives you the exact clarity you need to build better, smarter, and safer AI systems.